Hello, this is Rick Uptill with StruCIM to show how we would program a beam, an I-beam with stiffeners and gussets and an end plate. One way to do this is to read in the file in a CIS2 format, which is output from Tekla or design data. It's kind of a common format that we can use that has everything located in it. So we can either locate the assembly where it would be in the building, or we can just bring it in, and it's actually, we just brought it in and modeled it. It's right here, but I'm going to mount it on these tables. So we have two tables. We'll put it on station 2, and in this case there's an end plate here that's fastened there, so we want to reverse it. So this is a special clamp that clamps I-beams, and then there has to be some way to support this. There's a holder that allows it to rotate. Okay, so here we have 3 stiffeners over here, and a plate up here, and a plate down here, and an end plate. Okay, so this is read right in from the CIS2 file, and what we do next is we go through and we look at these parts. We call these subparts. So the way welding works is there's a main part, and that's this brown beam, and then there's these subparts, and they're all welded to it. And so we identify the welds associated with each one of these subparts. So these are all the welds. Let me move around here a little bit. Here's a stiffener right here. So if we click on the weld, we can kind of see that this weld has been divided into, so it starts in the center and then welds up, and then the yellow is the start, and then it welds this way. And what we're going to do is we're going to rotate the beam 90 degrees so these are up when it welds. Here's the welds for this plate right here. Okay, so what we can do is have the system automatically determine so that this downhand welding the angle of the table. So this is a 45. So what we'll do is we'll weld these first 2, and then we'll also weld these right here. And when this says ready, we've gone through and we've kind of taught some things about what kind of welds we want, what the weld process is. We can change the offset of the start and the end. We can do a lot of things to determine where we're going to touch for these, that kind of thing. So what I'm going to do is just start this this process going. This is just for these welds that we specified. So what we'd have to do if you wanted to weld this whole thing is to go back and specify all of them. So what we're doing now is we're moving the torch along. Here's a collision, and so now we have to decide how we're going to move the torch out of that collision. And so first we sacrifice push angle, and then we sacrifice work angle when determining where to put the torch. And these can be specified here on the weld elements, how you want to, what do you want a normal push angle to be, what do you want the normal work angle to be, and then we can also rotate around the orientation of the torch to clear it to get a weld working. Once the weld is good, it paints it green. Here there's not a lot of kind of manipulating of the torch to get it to weld. It's pretty straightforward. Same thing on this side. There's no collisions or anything like that, so those welds go pretty fast. Okay, so there's the program that's written just for this these welds right here. I'm just going to start it running. There's also a clean torch where after so many welds the torch will go clean itself, so you have a guaranteed clean torch when you're running. There's a process here where we touch with the torch, electrical connection, XYZ for each weld before we start, so that if it's off a little bit, then we can recalibrate that weld according to the touches. When the torch turns this purple color, it means we're actually welding. So in simulation, this is saying that we would send this program to the RICE controller, and have it actually weld this at this point. And there's different ways we can operate this. These stiffeners, in this case, we've decided to weld them in one continuous weld. I'm going to speed that up just a little bit. Or we can make them 3 different welds and have them weld. But once you've kind of figured out how you want each stiffener to be welded, then all of them will be treated pretty much the same. In this case, the only thing different is the gantry that moves the robot back and forth here. Okay, just for simulation, I'm going to speed it up again a little bit more. And there's the touch. Another touch. Here's the third touch. So now we've calibrated this this weld that's going to start on the bottom. We could also, depending on the weld, coordinate it with the rotating of the table. So there's different ways to get a weld that's a proper weld. But this is this beam is a standard profile in the CIS2 file, comes out of Tekla, so we can just look it up and we model it. And then these plates are part of Tekla, and we can model those as well. And then we determine the welds by colliding these plates with the model and figuring out the intersection, and then figuring out where the welds could be. Here we're going to do 3 touches. We did a touch on the beam, and then we touched twice the plate to get the XYZ starting location of this weld. And then on this side, we don't need to touch because we know where we've touched on this side, so we can use that same information here. Okay, so once you've programmed the beam, then you just have to say restart it and say save. And this will go through and it'll actually write out the RICE code. So you end up with the RICE robot code to perform the welding that you just did. Okay, so there it is. So we can look that up and just download that right to the robot. Station 2611 is the name of this beam. Alright, thanks very much.